These are the answers to the Ratios and Proportional Relationship Study Guide, which should help prepare you for your Ratios and Proportional Relationships interim assessment. So the first problem says, this graph shows a proportional relationship between the number of minutes, M, a pie factory operates, and the total number of pies, P, packed. Okay. Select true or false for each statement about the graph. Point P represents the number of pies packed in 70 minutes. Okay, so I see that the x-axis is represented by time, and right there it looks like that's the number of pies packed in 2.5 minutes, not 70 minutes, so that is false. The number of pies packed in 1 minute is 30. So 1 minute, go up. Yep, that is correct. It takes 4 minutes to bake 150 pies. So I look here, 4 minutes, and it is not 150. 150 pies would take a little bit longer, like 5 minutes. So that is false. Okay, this graph shows the proportional relationship between the number of minutes M Alex runs and her total distance D in feet ran. By the way, I forgot to bring up, these are proportional graphs. Like, first off, they mention it up here, but you'll see that it's a linear, meaning it's a straight line, and it passes through the origin. Okay? Okay, select true or false. Point A represents Alex's total distance after 2.5 minutes. So here's 2.5 minutes there, and then this y-axis represents distance. So yeah, after 2.5 minutes, she can go 5,000 feet. So that's true. Okay, the constant proportionality is represented by the point 1,501. So that means, like, okay, after 1 minute she can go, 1,500 feet. But the ordered pair that represents that unit rate is actually 1,500. Okay. So therefore, that is not right. And it's not 1,500. That's 2,000. So sorry, because it's counting by 1,000. So it's to be 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. Okay. So anyway, the ordered pair that would represent the unit rate is 1,2,000. So yeah, that's like way off. It's backwards and it's not even like right because X goes first and then Y. Okay, Alex ran 1,000 feet in 30 seconds. So I see the time. It's going by intervals of like 30. So 30 seconds, 1 minute, 1 minute 30, 2 minutes, 2 minutes 30 seconds. So 30 seconds she ran, 1,000 feet because it's in feet. This graph, the next graph, shows a proportional relationship between the number of hours worked, H, by OCL and his total pay, P, in dollars. So it's proportional because it's linear. It goes through the origin. And let's go ahead and look at the graph. The x-axis represents hours worked. The y-axis represents pay in dollars. So select true or false. Point O represents OCL's total pay after 3 hours. So we're jumping by 1 hour, 2 hour, 3 hours. And that would represent the pay. Yeah, that's true. OCL gets paid $9 per hour. So let's see. 1 hour, yep. And let's make sure this is counting by 9. So 9, 18, 27, 36. Yeah, that looks right. And then that would be 40, no. 36, 7, 8, 9. Oh, yeah, okay, 45, yeah. Okay, so he gets paid $9 an hour. If OCL gets paid $63, he would have worked for 7 hours. So $63 is what they give us. I'm going to look at $63 over here. So that would be this one, and it corresponds to here on the map, or on the graph, I mean. And he would have worked, let's make sure this is a 7. So we're counting by ones, yep, so that'd be 7 hours. That's true. Okay, Vadim sells snow cones at the fair. The profit he earns in dollars is proportional, this is proportional, to the number of snow cones sold. This equation represents a proportional relationship between the profit earned, P, so this is the profit, and the number of snow cones sold, S. I have a typo. This should say S. Darn it, I made a lot of copies of this. Okay, so now you know, that should say S, and I'm gonna have to remind the class. Okay, so enter the profit in dollars earned for each snow cone. So this is profit, $3 per snow cone, so the profit in dollars earned for each snow cone. They get $3 per snow cone, so it's $3. Okay, Alsatia makes beaded bracelets. The number of bracelets she makes is proportional to time. This equation represents the number of bracelets B made for every hour. Okay, so bracelets made per every hour. So enter the number of bracelets Al made per hour. She made 12 bracelets per hour. Okay. And if this was like on the SBAC, you don't need to put B equals, or you don't have to put B equals 12, just put 12, because it already says enter the number of bracelets Al made per hour, so she made 12. Okay, you don't have to be like B equals 12, just because that might confuse the computer that's scoring it, and that might mark it wrong, as we've seen in past interims. Colton works at a restaurant. His wage is proportional to the hours he works. This equation represents a proportional relationship between Colton's wage, W, in dollars, and the number of hours, H, he worked. Okay, so his wage is dependent on, looks like he makes this much per hour. Okay, so he makes $8.75 an hour. Okay, and you don't even need the dollar sign there because it says enter the Colton's wage in dollars, so it's assuming it's already going to be in dollars. So you can put that. Okay. 3 bags of cat food and 2 bags of dog food weigh 32 pounds. 4 bags of cat food weigh 32 pounds. All bags of cat food weigh the same and all bags of dog food weigh the same. What is the ratio of a bag of cat food to a bag of dog food? Okay, so this is how I would set it up. I would set up variables. C represents number of cat food. And I would use D to represent the number of dog food. Okay, now I go back up here. And actually, I would have to set up something called a system of equations, which I'll show you what that means. So 3 bags of cat food and 2 bags of dog food weigh 32 pounds. Does that make sense to you right now? Then they give us another sentence. 4 bags of cat food weigh 32 pounds. 4 bags of cat food weigh 32 pounds. Okay? So what I'm going to do is I'm going to solve for C first, just on this equation. So to solve for C, so when we built it, we started with C, then we multiplied by 4, so the opposite of multiplying by 4 is to divide by 4. Okay, 4 divided by 4 is 1. So the pounds of cat food is 8. Okay? Or not pounds, the number of cat food is 8. There's 8 of them. C is equal to 8. So I gotta figure out the number of dog foods. So I'm gonna take that C and substitute it back into this equation right here, okay? So when I do that, I need more room. So I have graph paper. Okay, so I take that 8 and substitute it in for C because that represents the number of bags of cat food. So 3 times 8 plus 2D equals 32. That's 24 plus 2D equals 32. Okay, we've simplified now, so go ahead and build it. Start with D, times it by 2, added 24. So first thing we gotta do is subtract 24 from both sides. 2D equals 8. Okay, now back up the ladder. Opposite of times by 2 is to divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. D is equal to 4. Okay, so back to the problem. What is the ratio of cat food to dog food? So cat food was 8. Dog food was 4. But then you're going to look at these multiple choice things and you're like, I don't have that. You did not screw up, don't worry. Remember, proportional relationships? You can like simplify it. So all you got to do is just simplify it. So what's the number that goes into both 8 and 4? Well, 2 goes into both, So an equivalent ratio would be, okay, divided by 2 would be 4. 4 divided by 2 is 2. Is that one of the options? Nope, let's simplify even further. Okay, a number that goes into both 4 and 2 is 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. So 2 to 1 ratio. Food. What was cat food? Okay, and then we see right there it's 2 to 1. And we have that right there. And that is B. Okay. I'm going to make sure I did cat food first, right? Cat food was 8. Yeah, okay, we're right. Okay, number 8. Okay. If you feel comfortable enough, I want you to try this one on your own. But I know you're probably like, what the heck did Hopkins just do? So that's okay. We'll do this one still together. I just need more paper because I just don't have any room. Okay, 4 bags of soil and 2 bags of gravel weigh 260 pounds. 4 bags of gravel weigh 260 pounds. All the bags of gravel weigh the same, and all the bags of soil weigh the same. What is the ratio of the weight of a bag of soil to the weight of a bag of gravel? Okay, set up your variables. I'm going to go ahead and use S for soil. Number of soil bags. I'm just going to go soil bags like that. And then G will represent number of gravel bags. Okay, 4 bags of soil bags, 4, and 2 bags of gravel weigh 260 pounds. 4 bags of gravel weigh 260 pounds. Okay, let's go ahead, and there's only one variable here, so I'm just going to solve for G right there. Okay, so in order to solve for G, all that we would have to do is go ahead and divide by 4. And I get G is equal to 65, okay? And they want soil to gravel. So I know it's going to be something ... 65. Okay, now let's figure out the soil. So I'm going to take this G, go back into that first equation right there. I know what the G is, so I'm going to put that right there. And I'm going to rewrite the equation, and instead of writing the letter G, I'm going to substitute that 65 in there. So the original equation was 4S plus 2, instead of G, I'm going to put 65. That is an S, not a 5. And that equals 260. I'm going to go ahead and simplify it before building it. 4S plus 130 equals 260. So we started with S, then we multiplied it by 4, then we added 130. So the first thing we got to do is subtract 130 from both sides. Right, okay. Okay, so 260 minus 130 is 130. Bring down your 4S. Now go back up the ladder. The opposite of times by 4 is to divide by 4, so we're going to divide both sides by 4. Okay, 4 divided by 4 is 1. 1 times S is S. 130 divided by 4 is 32.5. Okay? So I have G and then S equaled 32.5. Okay, so we want 32.5 right here because they wanted the soil to go first, because that's what it says right here, the ratio of the weight of a bag of soil to the weight of a bag of gravel. And that's a ratio. I don't see any of that right here, so let's go ahead and simplify it. And I think that 32.5 goes into both. Okay, so 32.5 goes into itself once. 32.5 goes into 65 twice. There's my ratio. Okay. Last problem of this type. 3 bags of beans and 2 bags of wheat weigh 32 ounces. 4 bags of beans weigh 32 ounces. All bags of beans weigh the same and all bags of wheat weigh the same. what is the ratio of the weight of a bag of beans to a bag of wheat? So I'm going to go ahead and represent this with, let's use B for bag of beans, I guess. Actually it'd be weight. What's the ratio of the weight? So beans. Why did that do that? Number of soil bags. These should be weight soil bags. I didn't read it right. Weight soil bag. Okay. Sorry. Okay, so weight of beans. And then W would be the weight of wheat. Okay. So 3 bags of beans and 2 bags of wheat weigh 32 ounces. 4 bags of beans weigh 32 ounces. Okay, let's go ahead and solve this one first. So to divide by 4, B equals 8. Okay, and they wanted what? Beans to wheat, so they want, this is the beans, so it's going to be 8 to something. Okay, let's take that B and substitute it in for the letter B right there. And I don't have enough room, so I will rewrite it right here. 3, instead of B we got 8 plus 2W equals 32. Okay, this right here is 24 plus 2W equals 32. Okay, now that we've simplified it, we can go ahead and build it. We had started with W, then we times it by 2, then we added 24. So the first thing you gotta do after that with inverse operations is to subtract 24. Zero. That right there is 8. So we have a positive 2W equals 8. Okay, then after multiplying by 2, we got to divide by 2 on both sides. 2 divided by 2 is 1. 1 times W is W. 8 divided by 2 is 4. So the pounds of wheat is 4 ounces. Okay, and I don't see that as an option here, so let's go ahead and simplify it. 8 divided by 2 is 4. 4 divided by 2 is 2. Do I see 4 to 2? Nope. Keep going further. 2 goes into both, so 4 divided by 2 is 2. 2 divided by 2 is 1, so 2 to 1. That's C. This table shows a proportional relationship between x and y. Find the constant of proportionality r using the value for r enter the equation in the form y equals r times x. Okay, so to find the unit rate, you know you got to go y divided by x, and it tells us that it is proportional. So I know for sure I'm multiplying x by the same value every single time. So I can pick any one of those. Yeah, so 12 over 3, 12 divided by 3. That's 4 over 1. So that's my unit rate right there, 4 over 1. That's r, because they want us to represent with r. So they want it in this format. So y equals, okay, instead of using the r, they want your unit rate times x. Or what would also be acceptable, since 4 divided by 1 is just 4, you can go y equals 4x also, okay? This table shows a proportional relationship between x and y. Find the constant of proportionality r using the value for r, enter an equation in the form y equals r times x. Okay, so I know it's proportional, so I know we're going to multiply x by the same value every single time, so I don't have to like go back and double check, do y over x for every single one, because it tells us it's proportional. We can assume that it is. So 2.5 divided by 10 is 0.25. Okay, 5 divided by 20 is 0.25. 7.5 divided by 30 is 0.25. So we're multiplying x by 0.25 every single time. Okay, and they want that format. Okay, and that right there is r, so y equals 0.25x. Or another acceptable answer, 0.25 is 1/4. Okay, so those are both cool. Okay, same instructions here. So y divided by x for the unit rate, I can go 2 over 20. Or I can go 3 over 30, because it's y divided by x. Okay, 3 divided by 30 is 0.1. So they wanted this format. Okay, and that goes there. So y equals 0.1x. If you said that out loud properly, it's 1/10, you know? So y equals 1/10 1/10 x. That's cool too. Okay, select the table that represents a proportional relationship. Okay, remember it's y divided by x. So 2 divided by 4 is 2, so 2, so we're timesing x by 2. 18 divided by 6 is 3. Okay, so I can stop right there. Those are already two different unit rates. So this one doesn't have a unit rate, it's not consistent, so that's not it. Okay, right here, 1/8 divided by 1 is 1/8, so our unit rate should be 1/8. 3/8 divided by 2, what is that? Well, that's definitely not 1/8. Yeah, it's that, and we wanted to get that, so that's not 1 either. Okay, 1/4 divided by 1 1/2. Okay, and I get 1/6. Okay, 1/2 divided by 3. That's also 1/6. Check them all. 3/4 divided by 4 1/2. You can go 0.75 divided by 4.5. Okay, and you also get 1/6. So I know that's probably it, but let's just double check this one. 1/4 divided by 1/2. 0.25 divided by 0.5 is 0.5. Okay, so this is 4/4 is really 1, so 1 divided by 2/2, that's really 1 divided by 1, so your unit rate is 1. So this is not it. So for sure this is your answer. Select the table that represents a proportional relationship. When you go ahead and solve this out, when you go 5 divided by 10, you get that the unit rate is 1/2 because you're multiplying x by 1/2. 4 divided by 8 is also 1/2. 34 divided by 7, that's 2. So 17 times 2. So that messes us up right there. See how it's important when it doesn't tell you it's proportional, you want to double check y divided by x every time because see how that throws us off. So that's not it. Okay, 8 divided by 1 is 8, so we're timesing by 8. Is 4 1/2 times 8 36? Nope. Wait, yes it is. Okay, 168 divided by 21. Okay, that's 8. So this is probably the answer. Just double check. Okay, 17 1/2 divided by 5. And I got 3.5. And then 21 divided by 6. I got 3 1/2. And then 2 divided by 7. I did not get 3 1/2. So that one's the one that messes us up. Okay, 1 divided by 2/9. Okay. And 2 divided by 5/9. Nope, not the same, so that's not it. That's the answer, is B. Okay, when you do this one all out, you're going to get C or D as the answer because the unit rate is 1.5 when you get there. Always remember to go y divided by x. Do it for, well, don't do it for the 0, 0. Do it for each one of the other values. And the second you get one that doesn't match, that's not going to be proportional. Okay? Or you type something in wrong in your calculator. Dylan makes an oil vinegar mixture as a salad dressing. She knows the amount of oil used is proportional to the amount of vinegar used. Which of the following could represent the relationship between the amount of oil and vinegar Dylan should use? Okay, so the key word here is it's a proportional relationship. So you need to look for a proportional graph. This one, it's linear, but it's not proportional because it doesn't cross through the origin, so no. Here it's linear, but it doesn't go through the origin, so no. This one, it starts through the origin, but it's not linear. This one, it fits the criteria, so this is the graph. Okay, Miguel mixes blue paint with white paint to paint his house a special shade of light blue. He knows the amount of blue paint is proportional to the amount of white paint used. Which of the following could represent the relationship between the amount of blue paint and white paint used? Okay, this one, it's linear, but it's not proportional because it doesn't start at 0, 0. Hey, this one looks like it could be it, but let's check the other ones. Nope. It's linear, but it doesn't go through the origin. It's linear, but doesn't go through the origin. So that's our answer. Jason works at a local water park. His pay is proportional to the number of hours he works. Which of the following could represent the relationship between the amount of hours Jason works and his pay? This is linear, but doesn't go through the origin. It's not proportional. And it tells us it's proportional. Okay, these are all proportional. Okay, nope, doesn't go through the origin, but it's linear, but it's not proportional. Hey, this one fits the criteria. This one, nope, doesn't go through the origin. So this one is the representation of Jason's pay. And it looks like he gets $10 per hour. This graph shows the linear relationship between commission earned, C, by a salesperson and the number of sales she makes, S. Okay, so cool. Find the constant proportionality. Okay, so let's find the unit rate. Oh, look at these order pairs. So this order pair is 1,6. This one is 2,12. So remember, you got to go y divided by x. So 12 over 2. So she gets $6 per every sale. Okay, so that's R. R is equal to 6 over 1. Using the value for R, enter an equation in the form C equals RS. So here's the form that represents the relationship between the commission earned, C, and the number of sales, S. So we just got to put that right there. So C equals 6 over 1S. Or you can also write C equals 6S. That's still cool too. This graph shows the linear relationship between hours worked, H, and a person's pay, P. Find the constant proportionality, R. Using that value for R, enter an equation in the form of P equals RH that represents the relationship between a person's pay, P, and the number of hours worked, H. Let's find that unit rate. So right here, this order pair is 110. Here is 220. So that's X. This is Y, X, and Y. So is unit rate Y divided by X. So we'll go 20 over 2, which is $10 per hour. Okay, they wanted that form P equals R times H. So the pay is equal to unit rate. There. Or you could put P equals 10H. Both are fine. This graph shows the linear relationship between time and hours, H, and the distance, D, a person travels. Find the constant proportionality, R, and then use that value and enter it in the, make an equation using that format, okay? So let's go ahead and find our unit rate. So that point is 6,270. I could have picked that one, but I ran out of room, so I can do this one. It's 1,350. Okay, I like this one. It's nice and small numbers. X, Y. So unit rate is Y divided by X. So I would go 270 divided by 6. And I got 45. What was it, 270? It was distance. So 270 miles for every hour. So 45 miles per hour. So our equation, and that's the unit rate, and they want it in the form D equals R times H. So it should be D equals 45 over 1 times H, or you can do D equals 45H. The reason I liked for you to write as a fraction, as you later found out, is because it helps you with slope. So this would be up 45 to the right one, up 45 to the right one, up 45 to the right one to graph your line. This one would have been up 10, right 1, up 10, right 1, up 10, right 1, put a dot, up 10, right 1, put a dot. If you were gone that day when we did just a mini lesson on slope, you're probably really confused. But that's why I always wanted you to write it as a fraction when you'd find your unit rate. Okay, this one can have more than one answer. Select all tables that represent proportional relationship between X and Y. And I'll do this first one with you, but I'm not going to sit here and divide everything because I'm going to show you the basic concept here, and then you can do it all yourself, okay? So remember, to find unit rate, you need to go Y divided by X. So 7 divided by 1, that's 7. So my unit rate is 7 over 1. 11 divided by 3 is 3.66666. So that would have been my unit rate, but actually there is no unit rate because this is not proportional. Okay, 3 divided by 0, you can't divide by 0, so don't even do it. 15 divided by 1 is 15, so we're multiplying X by 15 each time. 75 divided by 2 is, what is that? 37.5 times 37.5. Okay, you can see right there that that's not proportional. Okay, go 10 divided by 1/5. 10 divided by 1/5. I got 50. So we're going X times 50. 20 divided by 2/5. and you will get 50. It seems optimistic that this is proportional, but you want to check every single value in there because it doesn't tell us it's proportional. It's saying, hey, you find the proportional ones. And luckily, 30 divided by 3/5 is 50. 40 divided by 4/5 is 50. So yeah, this is proportional. Okay, again, y divided by x. So 3 divided by 2 is 1.5, so we're timesing x by 1.5. That's my unit rate. 6 divided by 4, that's also 1.5. So we're timesing x by 1.5. 12 divided by 8, again, unit rate is 1.5. 14 divided by 12, again, unit rate is 1.5. So there are 2 answers for that first one. Okay, the next ones, for each one of these, you need to go y divided by x, y divided by x, y divided by x. Okay, y divided by x, 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 and again, y divided by x, y divided by x, y divided by x. And you'll find that right here, your unit rate's 3 for each one of them. And right here, your unit rate's going to be 4 for each one of them. Okay, and then this one, you'll see right away, the unit rate is supposed to be 3, but then right here, 5 divided by 2 is not 3. Right here, your unit rate should be 1/8, and then 2 times 1/8 is not 3/8. Okay, your answers for this one, you should have gotten this one. Our unit rate was 6 times by 6. Okay, right here, it's not right. There's not a consistent unit rate. This one right here does have a consistent unit rate. I think it's like 1.14 or something. Then right here, our unit rate is 2 divided by 5. Yeah, this one, the unit rate's like 0.4 times 0.4 every single time. Okay, so there's 3 answers for that possible one. Make sure you know how to do it, okay? Okay, this diagram shows how much milk is mixed with flour for a recipe. Enter the number of cups of milk that is used for 1 cup of flour. Okay, now you want cups of flour on the bottom. So the milk goes on the top, 2 cups of milk. That says cups, milk, divided by 3/4 cup flour. So you can go 2 divided by 0.75 or 2 divided by 3/4, same thing. And I got 2.6 repeating per cup of 2.6 cups milk per cup of flour. Or 2.6666 repeating is really more precise, is 2 instead of like rounding it, it's 2 2/3 cups milk for every 1 cup flour. Those are both correct. This diagram shows how much red paint is mixed with white paint to paint Ella's room. Enter the number of quarts of red paint that is needed to paint per quart of white paint. Okay, that means white paint's on the bottom. So 1, 2, 3 quarts red per 1/4 quart white. When you go 3 divided by 1/4 or 3 divided by 0.25, you should get 12 quarts red for every 1 quart white. That says quart. This diagram shows how much peanut butter Hallie mixes with jelly to make her sandwiches. Enter the number of tablespoons of peanut butter she needs per tablespoon of jelly. So that means jelly's on the bottom. So here's how you'd set it up. 1 1/4 tablespoons peanut butter per every 1/2 tablespoons jelly. And you would go, you can go 1.25 divided by 0.5. You get 2.5 tablespoons peanut butter. I'm running out of room. That's just peanut butter for every 1 teaspoon or tablespoon jelly. Zoe has a 20. Oh, this is like one of the homework problems, number 5 on Thursday. Zoe has a 20-ounce soda pop. She drinks 15 ounces. Enter the percentage of ounces Zoe has left in her pop. There was a number of ways that the class came up with how to do this. This is just what I did. I just went, okay, she had 20 ounces. She drank 15 ounces. That leaves 5 ounces left. Okay? And she's got 5 out of the 20 ounces. Right? This represents how much she's got left. So I went 5 divided by 20. And that was 0.25. Well, to go from a decimal to percentage, you multiply it by 100. Or the same thing as of multiplying by 100 is moving your decimal place 2 to the right, which is 25%, because it wants the answer in percent. Enter the percentage of ounces Zoe has left in her pop. 25%. Okay. Now it says enter the percentage of ounces. So it's already assuming it's going to be percentage. So I think on the interim it's going to just want you to put like something like that. But if there's a percent button, I guess you can use it. Marissa has an 18-ounce water bottle. She drinks 16 ounces. Enter the percent of ounces Marissa has left of her water bottle. Had 18, drank 16. She's got 2 left. 2 out of the 18, which 2 divided by 18 is like 0.11. And then times that by 100 to get your percent. It's 11%. Timesing by 100 is the same as moving the decimal place 2 places to the right, remember? Erica has a 24-ounce bottle of orange juice. She drinks 18 ounces. Enter the percentage of ounces Erica has left in her orange juice. She has 6 out of 24 left. That's 0.25, which is 25%. Okay, this problem takes a long time, or it takes a lot of room. So I actually had to do it on a separate sheet of paper. Hold on. Okay. Gotta get organized here. Emily is buying a book at an online store. She can choose to use one of the 3 deals that are shown below. 5% off the purchase, not including shipping, of a hardcover book is deal 1. Deal 2 is 10% off the purchase, not including shipping, of an order of 2 or more items. Deal 3, free shipping on orders with a total over $25. The online store charges a flat rate of $4.99 for shipping. Emily's buying a book for $23.50. She could buy that same book with a hardcover for $2 more. Which option is the least expensive for Emily? Okay, I would start with your multiple choice stuff right here. Okay, and I would compare all of the values. So, buy the book without using any of the deals. This would be option A. Problem 31. Option A. It said buy the book without using any of the deals. So, like it says right there, that book was $23.50. But remember, she'd have to pay that shipping of $4.99. So there's the book plus the $4.99. That would equate into $28.49 once you added it. Okay, option B. Upgrade the book to hardcover and use deal number 2. Okay, so here's that book. Upgrading it to hardcover is $2 more. So here's the amount of that hardcover book. And remember, deal number 1 says you get 5% off the purchase. So here's that purchase. You're going to subtract 5% of that. So 5% as a decimal is 0.05 times that $25.50. This right here is $1.28. Okay, so $25.50 minus $1.28 is $24.22. But we still got to pay shipping, okay, because it says not including shipping. So I have this right here is that cost of the book after that discount, but I got to pay that shipping. So that's $29.21. So far, option A, not using any deals, is the most appealing, is the least expensive. Okay, letter C. Order another small item for $2 and use deal number 2. Deal number 2 says 10% off the purchase, not including shipping, of an order of 2 or more items. So she just gets the book, she can't use that deal. So let's go ahead and write that out. So here's the cost of the book. She wanted to buy another item for $2. That would be $25.50. Then it said, since we have 2 items, we are allowed to use 10% off. So 10% off of this. So 10% as a decimal is 0.1 or 0.10 times $25.50, because we want to take 10% off that amount. This value right here is $2.55. $25.50 minus $2.55 is $22.95. But remember, you got to pay shipping. So this deal cost $27.94. So far, that's the cheapest now. Deal C. Problem D. Order another small item for $2 and use deal number 3. Deal number 3 says, hey, free shipping on orders with a total over 25 bucks. Okay, so she would do $23.50 was that book. She wants another small item for $2. That would cost $25.50. Remember, shipping is free with a total over $25. That's a total over $25. There's my free shipping. That's the cheapest option. So your answer is D. Okay, number 32. I need more room. Okay, Danny is buying a book at an online store, and he can choose one of the 3 deals that is shown below. Go ahead and read through the deals. Okay. The online store charges a flat rate of $3.99 for shipping. Danny's buying a book for $22.43. He could buy the same book with a hardcover for $1.50 more. Which option is the least expensive for Danny? So again, we're going to go through every single one of these options right here and see which one's the best deal. Okay? And you should pause the video and try this on your own because, yeah, this type of thing is on your test. Okay, so option A, or not option A, answer A. Order another small item for $3 and use deal number 3. Okay, so the book he wanted to purchase was $22.43, and another item for $3 would cost $25.43. Okay, because deal number 3 says you get free shipping on orders over 25 bucks. That's over 25 bucks, so that's a total. Okay, that was option A. Option B says order another small item for $3 and use deal number 2. So here's the book, a small item for $3. That equals $25.43. But it says with deal number 2, we get 10% off the purchase, but not including shipping of 2 or more items. So we got to minus 10% off of this purchase. 10% as a decimal is 0.10. Or 0.1 times that 25.43, and this right here is $2.54. So 25.43 minus 2.54 is equal to, call me out if I'm wrong, okay? 22.89. But remember, you got to pay that shipping. The shipping was $3.99. So your total right here is $26.88. So far, this one's winning. Answer option C. Buy the book without using any of the deals. Okay, so the book, the book is $22.43, and there's that $3.99 shipping, so that cost is $26.42. Okay, so far this one's still winning. Answer option A. Let's try D. Upgrade the book to hardcover and use deal number 1. So upgrade the book to hardcover. So the book was this $22.43, but then you got hardcover for $1.50 more, and so that's $23.93. Deal 1 says 5% off the purchase, but you have to pay shipping. So we ought to get 5% off of this, minus 5% is 0.05, 5% off of that. This right here equals $1.20. $23.93 minus $1.20 is $22.73. But you got to pay that darn shipping, which was $3.99. So that plus that is $26.72. Okay, the cheapest option was A. Order a small item for $3 and use deal number 3. Okay, I don't know why I'm not being consistent. I X'd it there and then I filled it in, but I guess you get the point. Okay, Ivan's buying a book at an online store, and he can choose one of the 3 deals shown below. You yourself can read through those yourself. Okay. The online store charges a flat rate of $1.99 for shipping. Ivan's buying a book for $20.43. He could buy the same book with a hardcover for $2 more. Let's figure out which one's the cheapest option for Ivan. Okay, A, buy the book without using any of the deals. Okay, that book was $20.43, plus you got to pay that shipping of $1.99. So that brings a total of $22.43. That's A. B says upgrade the book to hardcover and use deal number 1. Okay, Okay, so that book was this much. That's a cool 3. Plus to get hardcover, you need $2 more. That brings you to $22.43. So deal 1 says you get 5% off that purchase. So let's go ahead and subtract 5% off of that purchase. So 5% off this, so minus 0.05 times that. Okay, and this amount right here is $1.12. And this minus $1.12 is $21.31. But you got to pay that darn shipping. That brings the total now to $23.30. Okay, so far, answer option A looks nice. Okay, B. Order another small item for $5 and use deal 2. Okay, so $20.43 is the book plus $5. That small item is $25.43. Now that we have 10% off the purchase is what deal number 2 says. So 10% is 0.10 or 0.1 off of this $25.43. This amount right there is $127. $25.43 minus $1.27 is $24.16. But shipping's not included in deal number 2. So we need to include that shipping of $1.99. So our total comes to $26.15. Dang, I'm going to go with A still because that's the cheapest. Okay, D. Order another small item for $5 and then use deal 3. Okay, so that book costs $20.43, but then that second item costs $5, so that brings us to $25.43. And then deal number 3 says free shipping on orders of over $25. Hey, there's free shipping. So it looks like that's our total right there. So comparing all the values, A is the cheapest still. A was buy the book without using any of the deals. Right? Yeah. Okay. That took a long time. Oh, good. We're on the last page. Hey, Leah buys a necklace for $16.50 plus a 6% tax. Elena buys a bracelet for $14 plus 6% tax. Enter the sum in dollars that Leah and Elena paid, including tax. Okay, so I'm going to just kind of separate the girls up here. So Leah's expense here, what is it, necklace? You bought a necklace? $16.50 plus, remember it's got that tax. You got to add that tax. 6% tax is 0.06 as a decimal times that $16.50. That value right there is 99 cents. So Leah's grand total, including the tax, is $17.49. Okay, and then Elena. Let's see, she bought, what did you buy? Bracelet, and it's got that 6% tax of that $14. So 0.06 times 14 is 84 cents. So it should be, your total is $14.84, Elena. Okay, but they want the sum. Sum means add. You got to add this plus this. So when you add them together, 1749 plus 1480, is that a 4? 4 equals 3273. Okay, that's one way you can do it. Another way you can do it is just add 16 plus 14. This is the other way. 16 plus 14. Oh wait, no, it's 1650. Sorry, Leah. You have a little bit more expensive necklace. 1650 plus 14 equals $30.50. Okay, and since it's the same exact tax, 6% and 6%, don't say it's 12%. No, it's not. You take 6% tax on that. 30.50 times 0.06 is equal to $1.83 tax. So you gotta take this amount plus that tax, plus that $1.83 tax, and you end up with the exact same answer, $32.73. So seriously, do it either way that makes more sense in your brain, because there's more than one way to do math problems. Okay, Ethan buys a book for $11.50. And then it's got an 8% tax. Mark buys a magazine for $2 plus an 8% tax. Enter the sum in dollars that Ethan and Mark paid including tax. So Ethan, $11.50 or 11.5, same thing, plus that 8% tax on that $11.50. This right here is 92 cents. So Ethan's grand total for his, including the taxes, $12.42. Mark bought a magazine for $2 plus that 8% tax on the $2. That comes out to 16 cents. So Mark's total is $2.16. The sum means you got to add them together, and you would end up with $14.58. Okay, or since it's the same tax, you can add this $11.50 plus $2 and get $13.50. And then don't forget that tax, $13.50 plus that, or $13.50, there's the, well, you can go $13.50 plus that, what was it, 8% tax? 0.08 of that $13.50. This right here is your tax. 13.5 times 0.08. $1.08 tax. $1.08. $13.50 plus $1.08 still gives you $14.58. Okay, Jackie buys a picture frame for $9 plus 7% tax on that $9, bringing her total to $9.63. And then So-Ann pays a buys a painting for $24 plus 7% tax. So $24 plus that 0.07 times 24. And that, what, this one came out to 63 cents tax. This one came out to $1.68 tax. So her total is $25.68. I hope you're not copying this because seriously, this is on the test. So if you're just copying this and you don't understand what you're doing, you're not doing yourself a favor. Make sure to bring questions back to me, okay? Okay, or if you like the other way where you add them together, 9 plus 24, and that's 33. And then you gotta go $33 plus that tax, 0.07 times the 33 bucks. This right here is $2.31 tax. So $33 plus $2.31 is $35.31, same thing. So do whatever way is more comfortable. Okay, Andrea uses 1.5 cups of water for every 1/4 cup rice when making a recipe. Enter the number of cups of water Andrea uses for 1 cup of rice. Okay, cup of rice is on the bottom. So we got 1 1/2 cups water for every 1/4 cup rice. Okay, so this divided by this, you can go 1.5 divided by 0.25, and you get 6 cups water for every 1 cup rice. So I think on like the interim, I think they would just want a 6. It says enter the number, so that's your number. Okay, Evan uses 2 1/4 teaspoons of garlic powder for every 3/4 teaspoons of salt for a spice mix. Enter the number of teaspoons of garlic powder Evan uses for 1 teaspoon of salt. Boom, 1 teaspoon of salt. Salt's on the bottom. 2 1/4 teaspoon garlic for every 3/4 teaspoon salt. So 2.25 divided by 0.75 is 3 teaspoon garlic for every 1 teaspoon salt. Sorry, it's so sloppy. I'm kind of getting sick of this. I'm sure you are too. Aveline uses 6 2/5 quarts of yellow paint for every 1/2 quart of red paint to make a special shade of orange paint for her bathroom. Enter the number of quarts of yellow paint Aveline uses for every 1 quart of red paint. So red's on the bottom. 6 2/5 quart yellow and 1/2 quart red. So if you're like, oh, what's that as a fraction? You can do this a number of ways. You could turn this into this mixed number into an improper fraction. So 5 times 6 is 30. 30 plus 2 is 32. So you can go 32/5 divided by 1/2. That's cool. Or you can go, well, what's this as a decimal? 2/5 as a decimal. 2 divided by 5. Oh, good. It's not repeating. So since it's 6 and 2/5, it'd be 6.4. We got to divide it by 1/2, which is 0.5. And we get 12.8. 12.8 cents. And you'd get that too if you did the fraction part. 12.8 quart yellow for every 1 quart red. Okay. All right. This was fun. Bye.